Okay, let's get started with serverless in PHP. So it's been said, sorry. There you go. My name is Matthieu Napoli. I work on a few open source projects like PHPDI, Couscous, Silly, Bref, which I will show in the presentation. I've worked on some PSRs like PSR 11, 15, and 17. And when I don't work on open source projects, I work at Null, a company I created where I work on serverless PHP project. So this talk is about sharing what I've learned, that experience about serverless in PHP. Now, if you don't know about serverless, that's fine. This is what we are here to learn about. We'll start very wide with what serverless is and move progressively towards PHP. And we'll see at the end some actual use cases in production. So the way I like to explain what serverless is to compare it with how we run applications in production today. So today, when we want to run a PHP application or whatever language, we think with resources. Like, how many servers do we need? How much RAM do we need? How many CPUs? How much disk space? We buy or rent these resources. We have to monitor them. We have to scale them. And we have to manage them, basically. Moving to serverless is moving from resources to services. With a service, I don't really care how the job gets done. It just gets done. Now, I will give you some examples to illustrate that, because maybe that's not really clear to you right now. Storage as a service is a really good example. Before Amazon S3, I would have to buy or rent a disk and decide on the size and monitor it and make sure it doesn't get full, right? Now, with Amazon S3, this is storage as a service. I can send as many files as I want, and Amazon's job is to keep them, to store them, to let me retrieve them, and to create backups and monitor everything. I don't have to deal with it. I just send my files and retrieve them. Now, we have many examples like this, like database as a service. If you've used Firebase, this is a serverless database. DynamoDB as well. We have caching as a service. Authentication as a service. Auth0 is a good example of doing authentication without having to deal with servers and with actually running stuff. Search as a service is also a really good example. Algolia is a serverless alternative to running your own Elasticsearch server. Now, why do we use services? And why use serverless? First of all, we have to manage much less stuff. This is now the provider's job, so I said Amazon, but it can be Microsoft Cloud, it can be Google's Cloud, it can be anything. But we don't have to manage as many things with services, of course. We can scale more easily because Amazon and Microsoft and Google, they are really good at scaling, and sometimes, most of the time, they are better than us. And what's interesting as well is that we only pay for what we use. If I take the Amazon S3 example again, I can, instead of buying and renting a 200 gigabytes disk to store like 10 megabytes, then I can just use S3 and pay only for those 10 megabytes. I pay only for what I use. And this can be interesting because in some cases, it's not, maybe most of the cases, I can actually save money. Now, there is one service in particular that is interesting to us developers, and that is function as a service. This is a service that lets us run code without having to deal with the servers. So of course, yes, there are servers involved in serverless. There are servers. We just don't manage them. We don't configure them, and we don't maintain them. So what is exactly function as a service? Here are a few examples, like 2 examples in Python and in JavaScript of AWS Lambda code. So AWS Lambda is function as a service, or FaaS, for Amazon, but there are many providers. The thing is that they all just look like the same. It's a function that takes an event parameter. The event parameter describes the event that triggered the function, and the function can do anything and return a response. In JavaScript, there is a callback because that's JavaScript, but it's the same principle. Now, that's great, right? But if you're like me, you build websites, you build APIs, and this is like event-oriented architecture. It's great, but what do I do with that? It's really different from what I do today. Actually, it isn't. Because what is an event? What will trigger the function? Well, an event can be an HTTP request, a message in a message queue, like an asynchronous job. It can be a cron, like every day at midnight, run this task. So even though it's called an event-oriented architecture, it's not really that different from what we are used to do, right? Now, let's say we want to run a web application. Let's go back to the roots of what it means to run a web application. And this is how I like to explain it. So let's say the green arrow is the event. It's an HTTP request. When there's the request, some code needs to run and return a response. So this is the blue bar. In reality, that is not how it works. It's more like this. You have the large blue bar, which is the server. And it runs all the time. And it waits for request. And when there is a request, it will invoke our code. Sorry, our controller, for example, our script. Now, moving to serverless, moving to function as a service, is moving from that architecture to this. It is now Amazon or Google or Microsoft's job to run the web server and to wait for requests. Our job is just to write the code that reacts to the requests. And so I've mentioned HTTP, but it works also for workers, for asynchronous jobs. You don't have to write the worker that runs all the time and waits for new jobs to process. It's now Amazon's job to do that. We just write the code that actually processes the job. Now, this is great in theory, but how does it really work? I mean, how does it work? Is it a Linux thing, and how does it connect everything together? Well, let's say you deploy your code on Amazon Lambda. And there is no event for now. There is nothing, no requests. Well, your code is not even loaded in memory. It's not running, because there is nothing to process. When there's the first request, like here, there will be a new Linux environment booted from scratch. It's like a Docker container, except it's not really Docker exactly. But it's the same thing. A whole Linux environment just for this request. Your code will be booted inside of it, and will process the request, will process the event. And then the whole container can be thrown away. Now, what happens if there are 1,000 requests at the same time, at the same exact millisecond? Well, this happens. Your code will be booted inside 10,000 different containers. 1,000 different containers, 1,000 times. So each request is processed by a single container. There is no interaction between the containers, there is no concurrency issue, there is no shared state. Every request is completely isolated from the rest. Now, of course, maybe you use PHP, and that doesn't seem so weird. But let's say you use Java or Node or Python or Go. When you run those applications, well, everything runs in the same process. You start the application, it starts to listen on the port 80, and the same server, the same process, will receive many requests. So for those applications, moving to serverless is a big architecture change. But for PHP, it's not that different from what we use today. We have Apache or Nginx as the web server, and then we have a new PHP process for every request. And this is why this execution model is really close to how PHP runs today. This is really, really interesting. PHP is in a special place for serverless. I would even say that PHP is the perfect serverless language. Okay, so now I've said 1,000 requests, we have 1,000 containers. How do these containers live? This will illustrate it a bit better, maybe. So at the beginning, no request, nothing, your code is not running. First request, a whole container here is booted. It processes the first request, and then it is actually kept alive. Amazons keep them alive just for optimization. On the second request, it can process the second request immediately. Then this container is busy, and a third request comes in. Since I said one container handles exactly one request at a time, a new container will be booted. And a fourth request comes in, a new container will be booted. That's how you can scale. It's like auto-scaling, but on a very, very granular level at the request level. And then after some time, and on Amazon it's exactly 10 minutes, but it depends on the provider. After some time, the container is actually killed. It's garbage collected, sort of. The interesting thing here is that we only care when our code is actually running. In between, the whole thing is completely frozen. And we only pay for when our code is actually running. We don't pay for when the container is waiting, because this is Amazon's problem. They decide to run it like this is their problem. They are actually optimizing this over time. We only pay for when our code is actually running, and this is the formula. Now, this is a little bit complex, I know, so I'll try to illustrate that differently. Let's say I have an application in production, an API or website, and the traffic looks a bit like this. So during the night, there is not so much traffic, and at 8 p.m., people start to wake up, and at 9 p.m., this is where I get the most traffic on the website. So when I decide to buy or rent a server, if I don't do serverless, I take a server that can handle the peak, right? At 9 p.m., the server and the whole setup is perfect. I pay exactly for what I should be paying. But the rest of the time, I pay for a server that is too powerful for my application. So if I were using serverless, I would pay only for what I actually use. I will pay something proportional to the green area here, right? So this is a bit abstract, but take your application graph, your production graph, and have a look at blue versus green. Because if I pay for a server, I pay for the blue and the green combined. If I use serverless, I only pay for the green, right? So to sum it up, the more blue you have, the more resources you are paying that you don't use. The more blue you have, the more money you are wasting. And the more blue you have, the more you could save by moving to serverless. And of course, it depends on the application. Some applications have more blue, have less blue, but it's still interesting to figure that out. Some applications have actually a lot of blue, if I can say. Workers, cron jobs, batch processes that we run during the night and that are really important to the business. These could be really more cost efficient on function as a service. So to sum up about serverless, in function as a service, we manage less stuff. When we use Amazon Lambda and similar providers, we don't deal with the actual servers. We don't deal with Linux and patching it when there's a security issue. We don't even deal with Apache or Nginx. We don't configure any of that. It just runs, it just works. Now, of course, this is new. Of course, we deal with less stuff, but the new stuff is sometimes more complicated to get started with. So it's not always magical. But with time and with experience, it gets really simpler. We can scale more easily because, as we've seen, the execution model means that since every container is completely isolated from the rest, we could run them in separate data centers at the other side of the planet, and we are theoretically limited by the amount of processors the amount of servers Amazon can make available. So we are really safe on that side. And we pay for what we use because we only pay for the actual time where our code is running. Now, I've mentioned Amazon Lambda, AWS Lambda, and this is the leading provider today. They were the first to start to create a function as a service offer. This is the most reliable and efficient and performant one. So if you want to get started, I really recommend to start with that. But there are many providers out there. There is IBM OpenWhisk, which runs with actual Docker containers, which is different from the rest. Microsoft Azure Functions, Google Cloud Functions, and you have many alternatives. Now, I've said that PHP is perfect for serverless. It's like the best language ever for serverless. But what's here ironic is that PHP is not supported on most platforms. PHP is not supported on AWS Lambda. That sucks, but that's okay. So now we're getting to PHP. From now on, I will talk mostly about AWS Lambda, because this is the one I have the most experience with. And so AWS Lambda doesn't support PHP, or at least there isn't an official support for PHP. Fortunately, last year, in November, AWS opened the API of Lambda. And you can now add any language you want on Lambda. People have added support for Haskell, Lua, COBOL, and this is actually a pretty big deal, COBOL. And you can add support for PHP. This is called a runtime. It's like a Docker image. You can add your own runtime. Now, if you want to do that, you have to take PHP sources, compile them for the specific Linux version running on Lambda. You have to make the specific configuration needed for Lambda, and you have to make some kind of bridges. That's doable, but I definitely do not recommend that you do that. Instead, I would suggest you use Bref. Bref is an open source project that brings support for PHP on Amazon Lambda. And it's actually more than just the runtimes. Bref, the goal with Bref is to provide to you everything you need to create serverless PHP applications. So Bref is not just about the runtimes. First of all, Bref is a set of choices. If you want to get started with serverless, you have a lot of options. You can use AWS, Microsoft, Google Cloud. You can use so many different deployment frameworks and configuration frameworks. There's a lot of choice. So instead of being completely swamped with all those choices, Bref makes them for you and guides you in a specific way so that you can get started easily. It comes with a lot of documentation, and that's really important because everything is new, so you need documentation to get started easily. And finally, Bref provides a set of tools, like the PHP runtime, obviously, but CLI tooling, dashboards, and small stuff that you may use and may need. So let's have a look at the PHP runtime, because there are actually 3 runtimes, 3 ways to run PHP on Lambda. The first one is the simplest, a PHP function. This is the function runtime. With that runtime, you can write the same thing as with other languages. You can write a function that takes an event and returns a response. So this is the most basic support for PHP on Lambda. And if you use AWS, if you know about AWS and Lambda, you know that this is really powerful because you can connect a lot of services together with that. But if you don't, if you just write websites and APIs, then yeah, that's cool, but I don't really know what I can do with that. That's okay. That's not the one I recommend you start with. The second runtime is the HTTP runtime. And to me, this is the most interesting one. Because you see, all languages on Lambda work like, this. But with PHP, we have the same execution model as Lambda. PHP is compatible with Lambda, which means we can run PHP FPM on Lambda. And this is what this runtime is about. And this is actually huge. This is what makes PHP completely different from the other languages on Lambda. We can take our applications, we can take our favorite frameworks like Laravel, like Symfony, and make it run on Lambda because it's the same environment. With PHP FPM, we have the same variables, we have the same SAPI, with the same thing as on any server. And finally, there's a third runtime. So I really recommend you start with this one if you want to get started. And the third runtime is more of a utility thing. Since on Lambda you can't SSH into the server, there is no server. You can't SSH and run like database migrations. So the console runtime lets you run like Symfony console commands or Laravel artisan commands on Lambda in production. You take your command and basically run it with Bref CLI, and it will run in production on Lambda. So you don't use that every day, but it's useful for deployments and for administrative tasks. Now, those are the runtimes. But how do I actually deploy my PHP code on Lambda? How do I create an application? So one way to do that is to take your code, make a zip file, and go on the AWS UI, create an account, and upload your code and configure everything. But if you've used AWS, you know that this is not the good option. AWS, the UI is extremely confusing, extremely complex. So you probably don't want to do everything by hand. Instead, what you want to use is infrastructure as code. And you have many options, but the one Bref chose is the serverless framework. The serverless framework is an open source project. It's one of the oldest projects related to serverless applications. And it's the most popular option today. If you want to create a serverless application in any language, that's the one you want to use. So the way it works is really simple. You have a YAML file, and you describe what you want to deploy. If you used Ansible, Chef, Puppet, CloudFormation, Terraform, it's the same thing. It's a YAML file. And here I will set the name of my application. I will say, hey, I want to deploy on AWS. And here I can list the functions I want to deploy. So here I'm creating an API. I can deploy multiple functions, but with most PHP applications, we just have one handler, one function, which is the entry point. Just like with Apache or Nginx, all requests are sent to index.php, and then my framework will route the requests. This is some boilerplate just to say I want to use PHP runtime from Bref. So you don't really care about that, it just works. And here, this is the way you say the event that triggers my function is HTTP. So here it's a way to say every request go onto this function. It's like a catch-all. Now I have my configuration and I can run serverless deploy. So I will install the composer dependencies optimized for production, run serverless deploy, and there you go. Serverless will configure your Amazon account, create everything necessary, and return to you the URL of your API or your website. Now this is AWS. The URL is really long, it's really complex, and it's really ugly. That's okay, that's how they do it. But of course, if you use your own custom domain, this will go away. This is just a temporary URL for development. The thing with serverless.yaml is that you can configure functions, but you can configure everything your application needs. Like if you want a database, you can create it with the YAML file. If you want a S3 bucket to store files and uploaded files and images, you can create message queues and like everything you need. So this is a good way to automate everything from the start. Now, I've mentioned it, but yes, you can run your favorite framework like Symfony or Laravel and your own framework if you want to on Lambda. And you don't really have to change anything except, it wouldn't be that simple otherwise, except now your application becomes distributed because the code runs on many servers at scale, or even just 2 servers is enough, that your application is now distributed. So you have to make it compatible with that. And I will give you some examples. The most basic ones are logs. You don't want to write logs on disk, because if the container is destroyed, or if you have 2 containers, then you have 2 log files, and you can lose logs. Instead, you want to send all the logs to a centralized system. Fortunately, that's really easy. With Bref, you just configure Monolog or Laravel or Symfony or whatever to logs and to write logs on the standard error output. And that's it. It will be sent to CloudWatch, which is Amazon's service, and it just works. Same with sessions. You don't want to write sessions on disk. Again, you will lose sessions, and they will not be shared between containers. So you want to use a database to store sessions, or Redis, or even store sessions in cookies. The point is, make your application distributed, and those are the little changes. Sometimes with modern frameworks, it's just one line change, but you need to make it. There is documentation for those 2 frameworks on the website of Bref, and tutorials to set up like custom domains, do local development with Docker. We have Docker containers to run everything locally. And like set up proper websites, deal with assets and everything. Now I just want to talk a little bit about performances. just to give you an idea, because this is often the one that we're like, what about performances? So first of all, you need to know that there are different kinds of lambdas. You can choose the amount of RAM your lambda will get. The more RAM you have, the more powerful the CPU will be. So basically, every time you double the amount of RAM, you double the power of the CPU that you get. You also pay twice as much, obviously. So these are the execution time of the bench.php script, which is PHP's official benchmark script, which is really CPU intensive. And I ran it on different lambdas. And as you can see, there's a clear difference. The conclusion is, don't use the slow lambdas. Don't use the small ones. Those are really, really cheap lambdas. What you want to do, and that's what Bref gives you by default, is the 1 gigabyte lambda. This lambda has a CPU that is as powerful as like a standard VPS server, like a DigitalOcean server, for example. So that's the one you want to use. To give you an idea, to compare, a powerful laptop with like an i7 processor runs the script in 0.6 seconds, from what I've tried and with different people. So those processors are actually really fast. So this is a good thing if you want to run really CPU-intensive stuff. Anyway, that being said, what about the response time? Is there any overhead running applications on Lambda, like websites and API? So I compared two scripts, a PHP Hello World, which is just an echo Hello World, and a Symfony Hello World with a controller that returns Hello World. Pretty standard stuff. It should be 0 milliseconds, right? Well, it isn't. But don't make the mistake of using the small Lambda. As soon as we use a proper Lambda, we can see that the response time is actually really low. The execution time of PHP is like 1 millisecond or 4 milliseconds for Symfony. And this is exactly what you get when you run PHP or Symfony on a server. So basically, there is no overhead to running your application on Lambda. Now, there is one thing I didn't mention. One problem. And those are called cold starts. Because yes, when the container starts, when the Linux environment boots, that's not 1 millisecond, right? That's more than that. And here is a comparison between languages. And basically, you have like 250 milliseconds delay whenever there's a new container that needs to boot. So when you have a new request and your website had none for a long time, or whenever you need to scale up. So this isn't really ideal. If you do real-time applications, like if you want your application to always respond in less than 10 milliseconds or 50 milliseconds, this is not good. Don't use Lambda for that. That's fine. But my point is that for most applications and for most websites, this is acceptable because you will get cold starts from what I've measured on production applications, about 0.5% of the requests. So you need to judge whether this is okay for you, whether this is acceptable. One thing to keep in mind, two things to keep in mind. First of all, Amazon is continuously improving those cold starts, because as soon as they can improve those, they can shorten the life of the container, which saves them money. In 1 year, they've been divided by 2, so I really can't wait to see how they continue to optimize that. And the second thing to keep in mind is that with the Lambda architecture, you never get to the point where you have a sale at 8 a.m. There's a sale and everybody rushes onto the website. And you had good response time, but now everything is so slow because the server is overloaded. Maybe it will scale up if you have auto-scaling, but it takes some time, And so you have slow response times, even though your application should respond in like 50 or 100 milliseconds. Here, with Lambda, you will get cold starts. But that's the worst you can get, because there is no CPU to overload. There is no memory to fill. It will scale and handle exactly 1 request per container. So this is the worst case scenario. And if it's acceptable to you, then that's a good candidate to run your application. Now, I have a few case studies to show you. Those are real applications running in production with Lambda and Bref. And the first one is externals.io. So externals.io is a small website I built to view the PHP internals mailing list with a nicer UI. You don't have to subscribe and get tons of emails. You can just get on the website and view all the threads and even vote on the threads. And when I started working on that, I ran it on the server. So it's a pretty standard thing. It's a website, a PHP website, with good response time. I'm really happy about that. There's a cron job running every 5 minutes, fetching new emails on the mailing list. And then it sends them in a MySQL database. It's a custom PHP framework, because I just wanted to have fun on this project. But it's not like a framework you want to reuse, definitely. And it gets about 100,000 requests per month. So there's a little bit of traffic, which is great. Now, I migrated that from a platform message hosting, which is like a server, let's say a server, and the hosting cost me $50 per month. Now, I migrated it to Lambda, and now it's costing me $17 per month. Now, on the $17, I have $15 per month for the database. I have $2 per month just for running the code. So I would say that Lambda is most of the time pretty cheap to run your websites and APIs. The great thing as well is that I don't have to deal with anything. I had downtime issues before, now I don't. I don't have to deal about and worry about scaling up, about my servers going slow, and about being overloaded. It just works. Now you may be thinking, yeah, but what if there's a big traffic spike and everything scales up and I have tons of containers and then I will pay like a lot, right? And that's true, you pay more. Here is an example of the externals website when in August, Ziv Zuraski published an RFC called P++. Maybe you've read about this. It was a suggestion for a new version of PHP. And it got a lot of attention. People rushed onto the website and wanted to read about it. So I got about 10 times more traffic at the time. And this cost me an extra 4 cents for the traffic spike. Because yes, that's how, I want to say cheap Lambda is. At scale, obviously, we are talking about large amounts of money, but still, compared to a server here, it just worked, and I didn't have to worry about all of that. The second case study is PrettyCI. PrettyCI is a SaaS that runs continuous integration for coding standards. Basically, you push your code to GitHub, then PrettyCI's API gets a webhook, and the PrettyCI will analyze the commit. So it will run PHP code sniffer or PHP CS fixer on your commit. And it will report back on the pull request, is it green or is it red? I built this as a Laravel application. I deployed that on a DigitalOcean server, which cost me like $5 a month. And I set up the website, it worked perfectly, and I used Laravel queues and workers to run the jobs. So whenever there's a webhook, I push in a message queue, and then I have 4 workers. And one worker will pick up the message and process the commit. The thing is that when I get 5 people pushing at the same time, then I have someone waiting for the job to finish. And I have 2 solutions. Either I keep people waiting, or I add more servers and scale up and add more workers. And I didn't want to deal with servers. I don't like dealing with servers. So I moved the workers to Lambda. And this is what I often get now. Jobs run really fast, like in 5 seconds most of the time. And more importantly, people never wait. This is what I often see, like PrettyCI is green because it has finished, but other build systems aren't even running the test. They are just pending, waiting for containers to be free. Here I have a message queue that basically there is never a queue, because as soon as there is a message in the queue, a worker will boot and process it. So this is a great way to completely scale your worker queues and process a lot of messages really quickly. Now, I don't deal with scaling, and it just works, and it costs me like a few cents every month. I'm really happy about that. Next, Enoptea. Enoptea is a French startup, And what they do is they analyze and process energy bills. So they extract information from PDF files, and they don't have a lot of traffic, but they have a lot of background jobs. These were statistics from last summer. But since they are a startup, they are growing, signing on more and more clients, and every month they had to deal with more jobs. And they started having trouble scaling. They were running jobs with PHP on EC2, so it was a completely classic job queue and workers, and they added more and more servers, and yeah, they had trouble scaling up. They also had trouble with their Amazon bill growing up. So what they started to do in July is they started migrating their workers to Lambda. And from the moment they started migrating, they started decreasing their Amazon bill. Now, I can't give you specific numbers and absolute numbers on the total bill, but I can show you an example of one microservice with workers that they migrated entirely from EC2 to Lambda. And they went from $800 per month to $90 per month. That with a better service. Because before they had some jobs that were lost because of overcrowded servers, of workers that were waiting. They had a job that took 2 hours to process with many different sub-workers. But now it runs in less than 10 minutes. So they saved money, they scaled much more easily, they were not afraid anymore to sign on big clients, and for them this has been a huge success. And finally, the last one, it's a website. It's called Sua Musica. It's a Brazilian website, and it's about, I'm not really familiar with it, but it's about sharing stuff about music. It's a website backed by an API, built in PHP, with Falcon and MySQL, completely standard, except that Falcon maybe is a bit unusual, but it's okay. They have good response time. And they actually have like a lot of requests. 40 million requests per day. They are in the top 3,000 websites in the world. They run PHP, and they used to run it on EC2 and ECS. And they migrated to Lambda and to PHP using Bref. At peak time, they have 2,500 containers alive. That's the number of requests they have in parallel. And when doing the migration, they saved 25% on their bill. So they saved, like, at their scale, that's a lot of money. So even for large websites with a lot of traffic and like continuous traffic, they saved money. And they are now really happy with it because they don't have to deal with auto-scaling, with configuring everything, fine-tuning, and dealing with the servers. So for them, it was also a really good change. Now to conclude, well, what should we conclude? Should we go tomorrow or in 2 days at work and migrate everything to Lambda? Okay, probably not. Because we need still some experience. You probably need some experience with everything. You need to learn about it. You need to practice with it. You don't like learn containers or Git. You didn't learn that in a single day, right? But this is definitely an interesting technology. Is serverless the future? I don't know, maybe. But for sure, that's a really interesting and promising technology. It will be part of the future, I have no doubt about that. It is not for every application, but it opens up a lot of possibilities for most applications. Is PHP's future serverless? Well, I don't know about that again, but the fact that PHP's identity, as it was explained by Erasmus earlier, PHP's origin is about simplicity, it's about getting things done, it's about the shared nothing architecture and just making sure that things run well. We have the same goal, simplicity, doing less stuff, with the same principles, I would say, which is, shared nothing architecture. We have an alignment of stuff that is completely unique and extremely exciting. So I would really encourage you to have a look at it, give it a try, really. Try a small application, you will see how promising this is and how useful it can be in real application. Learn about it and share what you've learned. Because this will probably stay for a long time. Thank you so much.
You have a lot of questions here, so get ready for that one, okay? The first one, I guess, it's typical for any serverless talk. It's about creating either offline or local dev environments, all that sort of stuff. What recommendations would you?
So you mean for local development?
Well, I guess the person who asked, there are 20 likes, so I guess, yeah, for local development, I guess,
okay,
essentially.
For local development,
Sorry, guys, can you, like...
Yeah. For local development, there is a completely Docker stack. So you have a Docker Compose file that you can drop in your project, and it will give you something just like running LAMP locally, and it just works. So yeah.
And I guess dev environments, just another set of serverless stack.
Yes, for a custom domain, yes. There is a documentation and tutorial about that. So you have to create a CNAME if you know about domains. You create a CNAME to a specific endpoint in AWS, and it works.
Then there's another question about, Azure especially had lots of incidents lately, so your recommendations for handling those things, because serverless, like...
Yes, yes. So yes, definitely if you host something on a cloud provider, you will go down when they go down. If Amazon S3 go down, if Azure goes down, a lot of websites go down. But to me, I'm fine with it, because I would go down much more often than they would. So I'm fine if they go down like once every year.
I know what you mean.
That's okay. I mean, you can maybe try to mitigate that by running in different data centers and in different regions across the world. That's possible. But it depends on your use case. Don't overthink it if you don't need that.
Then someone is asking about if AWS or either other providers have some sort of like DDoS attack so that they don't charge you for those requests or something like that?
Yes. You can throttle the amount of requests coming into your application. You can say, I just want like maximum 2 containers running. So that's a good way to limit your bill. You can use AWS services to throttle and block DDoS attacks. There are a number of ways to limit impacts like this. And again, if you have a small website, you say, I want a maximum 2 containers, that's really safe for you.
And someone is asking, I think you mentioned that, but like comparing the cold start time versus latency on a normal server, all that sort of stuff, like, where I guess people are asking about the sweet spot or like...
Yeah, so for application I run, I get like 0.5% of cold starts, but there are ways to mitigate that. You can, for example, run a pingdom on your website. Every 5 minutes you get an HTTP call, and that keeps your container alive. So many people do that. It's really simple, and it doesn't cost a lot, like it's a few cents a month. So there are a lot of ways to improve stuff like this.
And another one cost-related, and I think we're going to end here because we're running out of time. It's about the scale of cost. Like, at what point is it cheaper or like more expensive? Like, if your service becomes popular over time,
Okay, there is
more or less.
Yes, I would say it really depends. But most small applications are cheaper on AWS, except if you have a database. A database costs $15 a month that's the minimum price. Yeah. But if you don't use a database, it starts at 0. I run websites at $0 every month. And after that, when you scale, most of the time it's cheaper. If you want to get an ID, there's a cost calculator on the Bref website that you can input how many requests you get and see how much it really costs on Lambda. So that's an estimation, but it really helps to get an ID.
And I guess we have some time for some question on the audience. I know we have more questions. Will you be around for a while, so
really
that these guys can keep asking you? Because
really happy to come and discuss that with you.
Sorry about asking, but we have like plenty more. Anyone wants to ask anything else before lunch? No. Okay. I didn't see that one. Okay, sorry about that.
Who manage the migrations with the serverless environment?
Okay, that's a really good question. Migrating can take some effort. For example, for the externals website, it took me maybe half a day configuring stuff because I had a custom framework. I want to make it really easy for Symfony and Laravel, basically, so that you can just get started. But yeah, you need to first try on a small application, even a new application, and then you can really get your head around it and estimate for larger applications.
No, está ahí detrás.
What about data privacy protection, such as ICO certification and NAN certification with Google or Microsoft or any other party?
Okay, I'm not an expert on that, but I know that AWS and most cloud providers have some things about compliance with GDPR and with some ISO stuff, for example, for medical records. You can host your websites, for example, I live in France, so I can host websites in the French region, which complies with some of the French restrictions on some services. But it really depends on your use case, honestly, and I'm not really an expert on that.
Okay, guys, so let's go for lunch and see you later in the afternoon.
Thank you.
Thank you very much.
That sounds great.